So this is my part. There is a baseline energy consumption. So I take 7 months in 2020 from June to December. What we see on the graph, the June the energy consumption on kilowatt hour is 4010, July 3071, August 3093, September 3089, October 3082, November 4056, and lastly is December 4013.7. So this is set energy and saving target energy for energy consumption. So I will do the time dependent analysis. For this time dependent analysis, what we see that have a 7 month, and then energy consumption in kilowatt hour. The day per month, they use the energy they use. So I get the total of energy consumption kilowatt hour after I add all kilowatt hour in June to December. So the total is 2,818.8. So the based on the graph, we see on the November there is a maximum total use, and on the July the minimum is 3,317.1. So based on the graph, we get the average is 4,005 kilowatt hour. So we'll continue to building energy index. So how I get the total is from the monthly kilowatt hour, I divide by area of hour. So what we see on June, the monthly kilowatt hour is 4010 divided by area of house 3018.4. The total is 1.06. Next is June. The monthly kilowatt hour is 3071. The area of house is 384. The total I get is 0.966. Next is August. The monthly kilowatt hour is 3,019.3. The area of house is 3,018.4. So total I get 1.02. Same like December. The monthly kilowatt hour is 3,018.2 divided by area of house 384. The total is 1.01. And then on October, the monthly kilowatt hour is 3,018.2 divided by area of house 384. I get the total 0.9. On November, I get 1.18, and lastly December is 1.138 the total. So the total of kilowatt hour, the total building energy index for 7 months is 7.3906. Next, I proceed to identify and measure the energy consumption for each electrical application in-house. So I proceed to how to calculate the application in June 2020. First is I take the lamp the watt is 18, the unit is 12. So total watt, how to get total watt is 18 times 12, and you get 216 watt. So, and then you 216 watt, you time 8 hours per day that you use. So you get 1728. That is energy that you use for 1 day. Next is water heater. The watt is 4,000. The unit is 1, and then after you time watt and unit, you get total watt is 4,000 for that, and then you multiply by hour that use, the energy used is 4,000. And then the rice cooker, same like that. The watt is 415 times 1, and you get total is 415. So the hour that used in rice cooker is 2 hour, and total you get energy is 9,900. After you calculate the watt and unit, you can get the total watt. After that total watt time to number of hour, and you get the energy that used in 1 day. So how I get the total is I plus all the energy, and I get 46,483 watt. So how to calculate the in kilowatt hour per day is I take the energy watt is 46,483 divide by 1,000, and you get is 46.483. Next, how to use the per month in kilowatt hour is first you take the per day kilowatt hour is 14,6.483. You for 46.483 times 31 day, and total per month you can get is 1,414 and 1,414.973. This is total for there is a total for June 2020. Now I proceed to July 2020. So for example, I take the air condition. The kilowatt hour is 1015. The unit is 1. The total kilowatt hour after watt time to unit is 115. So total that use in per day is 4 hour. So of 1015 time 400 4,000 4 hour, and we get 6,000. So after calculate the lamp and after calculate the total watt, we plus all and we get the energy per day is 29,673. So how to calculate energy consumption per day is 29,673 divide to 1,000, and we get 29.673. So this is a kilowatt hour per day. So how to get per month? What we see on the baseline, the day on July is 13. So how to calculate is we take the per day kilowatt hour in we take 29.673 times 13 day, and we get 819 and 19 and 819.9 819. Next I proceed for August in 2020. I take the washing machine. The watt is 700. The unit is 1, and the total watt is 700. So how many time that use in per day is 3 hour. So 700 times 1 unit, and we get total watt is 7,000. And then we calculate time by 3 hour, and the energy for 1 day the watt is 2,100. And same like previous, how to calculate the energy consumption per day. So we take the energy per day, total days is 7,008. So same like previous, we calculate is 13,7 and 14 14.8 watt divide by 1,000, and we get 37.048 per day. That is a kilowatt hour per day. Now, how to get the month? We time 13 one day. So 3000 3 points 37.04 37.048 times 31 day, and we get the 1114.8 that is on August. Next we see on September. I choose to one is fan. For example, the fan, the watt is 75 watt, and that has a 5 unit, and 75 times 5 unit, and I get a 375 watt. So the hour that used is 15 hour times 375, and the energy I get is 5626. So the total energy I get from all application that use in per day. So total kilowatt hour per day is 33,410 divide 1000, and we get 13.341 kilowatt hour. So in September they have 31 day. So 33.41 times 13 one day, and we get 1000 wait, okay, 1013.71 kilowatt hour per month. Next, on October, the same. We choose the printer. Like the watt is 14.5 kilowatt, 1 unit time 1 unit, and you get the total watt is 14.5. After that, you time 1 hour per day, and the energy that used is 45. Yes. So after calculate the all energy in application, and we get the total energy. The total energy is 13,701. So we want to calculate the kilowatt hour per day. We divide by 1000, and we get 13.2.0 4.71 kilowatt hour. And October, that change of day, and we just multiple by 13 day. So 32.71 times 13 day, and I get 981.3 kilowatt hour in monthly for October. Next, on November, we choose the laptop. The watt is 15 kilowatt hour. They have many unit. There is a 7, and total watt is 315. So the time that used is 8 hours. And total energy for laptop, we get 2018 watt. So same like previous, the energy we get is all after all the total energy, and we get 3,835 watt. So how to calculate the per day is 15,313.5 divided by 1,000, and we get 15.835. On November, we have 13 1 day. So just multiple 5 15.835 times 31 day, and we get 1,616.885. Next, we proceed to another month. The lastly is December 2020. How to calculate this? Same like previous, same like the June, from June to November. So the all energy, total energy in December that used is 8,985 watt. So we divide, how we want to get the per day is just divide by 1,000, and also the 48,985 divide by 1,000, and we get the kilowatt hour per day is 8.985 kilowatt hour. So the monthly in December, the day is they have a 31 day. So just multiple the 48.985 times 31, and you can get the total of kilowatt hour per month is 1,469.55 kilowatt hour. So we calculate the all application in house like included the iron, lamp, freezer, air condition. So this is the total kilowatt hour we get in per month. So what we see on June, the kilowatt hour is 1,414. In July, 819. August, 1,148. September, 1,013. 5. October, 981. November, 1,016. 1,616. 8. Lastly, is on December is 1,469. So after we calculate the all 7-month electrical kilowatt hour application, the total is 8,613.5. So what we see, the maximum electrical application per month is on November. So the minimum on July. So the average electrical application is the best 1,213. So this all for my part. Thank you. I will present the another part to my friend. Thank you.
Hello, my name is Siti Noshamimin Shafika binti Anwar. My matric card number is B0618100198. Today, for my part, I will explain a little bit about develop the learn approximate percentage of each equipment. Water heater is dominant for 205.44% because water heater is 4,000 watts. The lowest is lamp for 1.79%. It is 18 watt for the load equipment. This I put a list of equipment June until December.
Hi, a very good day to everyone. My name is Muhammad Akmal Fikri Kamal from Btmm section 1. So I will continue my slide presentation, which is about the way to propose energy and cost saving measure. There are many ways to propose energy and cost saving measures for the house, which are replace our light bulbs, use smart power strips, install a programmable or smart thermostat, adjust our day-to-day behaviors, and so on. So I will explain to you several ways, which firstly is replace our light bulbs.
Traditional incandescent light bulbs consume an excessive amount of electricity and must be replaced more often than their energy-efficient alternative. Halogen incandescent bulbs, compact fluorescents like CFLs, and light-emitting diode bulbs (LEDs) use anywhere from 25 to 80% less electricity and last 3 to 25 times longer than traditional bulbs. Although energy-efficient bulbs are more expensive off the shelf, their efficient energy use and longer lifetimes means that they cost less in the long run. Secondly is use smart power strips. Phantom loads, or the electricity used by electronics when they are turned off or in standby mode, are a major source of energy waste. In fact, it is estimated that 75% of the energy used to power household electronics is consumed when the smart power strips, also known as advanced power strips, eliminate the problem of phantom loads by shutting off the power to electronics when they are not in use. Smart power strips can be set to turn off at an assigned time during a period of inactivity through remote switches or based on the status of a master. And lastly is install a programmable or smart thermostat. A programmable thermostat can be set to automatically turn off or reduce heating and cooling during the times when you are asleep or away. When you install a programmable thermostat, you eliminate wasteful energy use from heating and cooling without upgrading your HVAC system.
That's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Umi Kalsum binti Abdul Qadir and I would like to present my part, financial analysis. This table is our group summary of energy conservation measure table of 7 months from June to December 2020. First is our group choose to install new LED lamp 10 watt from old lamp 80 watt. And the energy potential saving is 342.40 and the cost potential saving is 176.47. And the investment cost is 190 and the simple payback period is 0.2. Second is make change the oil of refrigerator to the eco-friendly brand. And the energy potential saving is 619.32 and the cost potential saving is 250.38. The investment cost is 739 and simple payback period is 5.91. Last is change water heater from 4,000 watt to 3,060 watt. Energy potential saving is 878.4 and cost potential saving is 340.33. The investment cost is 280 and the simple payback period is 2.31. That's all.
For implementation plan, first one is refrigerator. Low cost measure of refrigerator is use power saving mode. It will reduce 20% of energy. That equal 622.08 kilowatt per hour and will cost 243.86 cents. Medium cost measure for refrigerator is first one, clean refrigerator condenser coil. It will reduce 30% of energy, that is 544.32 kilowatt per hour and equal 203.70 cents. The second one is frequently check refrigerator seal. It will reduce 7% of energy, that is 120 kilowatt per hour and it will cost 26.16 cents. The high cost measure of refrigerator is upgrade to energy efficient star model refrigerator. It will reduce 50% of energy consumption, that equal to 448 kilowatt per hour and will cost Rm 114.37 cents with investment of Rm 3,500 ringgit. Next one is washing machine. For low cost measure of washing machine, first one is wash clothes in cool water. It will reduce 40% of energy use, that is 97.2 kilowatt per hour and will cost around 21.20 cents. Second one is switch off power on the wall. It will reduce 50% of energy, that is 145.8 per hour kilowatt per hour and will cost Rm 31.80 cents. The high cost measure of washing machine is choose an Energy Star model washing machine. It will reduce around 36% of energy, that is equal 108 kilowatt per year and will cost around 23.55 cents with investment of 1,099 ringgit. Payback period per year is 0.02 cents. For low cost measure of computer, the first one is switch off when not used. It will reduce 50% energy. That is 27 kilowatt per year per hour and will cost Rm 5 ringgit and 89 cents. The second one is turn on power saving mode. It will reduce 20% of energy. That is 36 kilowatt per hour and it will cost Rm 7.85 cents. The medium cost measure for computer is use efficient energy computer. It will reduce 30% of energy, that is 55 kilowatt per hour and will cost Rm 11.77 cents. The cost of investment is Rm 2,180. For low cost measure of television, the first one is switch off when not used. It will reduce 20% of energy, that is 44 kilowatt per hour and it will cost 9.6 cents. The second one is turn down the brightness. It will reduce 50% of energy, that is 50 kilowatt per hour and it will cost Rm 10.9 cents. The medium cost measure for television is use Energy Star model television. It will reduce 30% of energy, that is 37 kilowatt per hour and it will cost Rm 8.1 cents. With investment of Rm 2000, payback period will be 0.060 per year. Low cost measure for aircon is use power saving mode for aircon. It will reduce 20% of energy, that is 120.08 kilowatt per hour and will cost around Rm 135.16 cents. The medium cost measure for aircon is first one is clean aircon filter. It will reduce 30% of energy, that is 542.32 kilowatt per hour and it will cost 118.16 cents. Second one is frequently check aircon gas. It will reduce 7% of energy, that is 118 kilowatt per hour and Rm 16.80 cents. The high cost measure for aircon is upgrade to inverter type air conditioner. It will reduce 50% of energy, that is 446 kilowatt per hour, that costs Rm 97.22 cents. With investment of Rm 2000, we get payback period of 0.03 per year. Low cost measure for electric heater is first one, switch off when not used. It will reduce 15% of energy, that is 20 kilowatt per hour and will cost around Rm 4 ringgit and 36 cents. Second one is constantly clean slice to speed up heating process. It is 18 kilowatt per hour and it will cost around Rm 4 ringgit. The medium cost measure for electric heater is upgrade to thermopop water heater. It will reduce 20% of energy use, that is 50 kilowatt per hour and it will cost around 3 ringgit and 27 per year. With investment of Rm 135 ringgit, payback period per year is 0.73.